Hey everyone. I think one of the things that this channel needs is some practice videos, right? So by now I've covered all of the rules for truth tables, and we've kind of gone over all of the logical connectives and whatnot, right? And if you haven't watched those, you should watch those first, right? Or I mean, unless you're already really comfortable with how the logical connectives work, right? But if this is your first time doing this, definitely start by watching the other videos first, right? The ones where I cover how to evaluate all of the logical connectives. In this video and in future practice videos, right, I'm just going to assume that you already understand the basics, right? And we'll just go from there. All right, so let's go ahead and get started. We're just going to do some easy, we're going to do 3 relatively easy truth tables in this video, and I'm just going to work through these. This isn't really scripted or anything like that. I haven't solved these before or anything, right? But we're just going to go ahead and dive right in. So I'm going to put my tablet up on the screen, and you'll forgive me for looking down while I solve this, right? But okay, so looking at this problem, we've got a really basic one, right? So the argument is just, so actually before we even get started with the argument, remember, right, that this part here of the truth table isn't actually part of the argument. That's just where we lay out our truth values, and I've already laid these out just to make life easier for us. But okay. So the argument says P implies not R, not P and R, therefore R implies not P. And we're going to be testing to see whether this argument is valid. Now, because all of these are relatively straightforward, there's no real first premise that I think it's better to start with. So I'm just going to go ahead and start with the very first one, right? So we'll go ahead and we'll start here. All right, so let's see. Before we can evaluate this conditional, we have to start by evaluating the negation, right? So that's the place where we got to start. All right, so I'm going to go ahead and highlight just for the sake of ease, right? Here are our truth values for R, right? So if R is true, then not R must be false. If R is false, then not R must be true. If R is true, then not R must be false. And if R is false, then not R must be true. I promise not to go quite that slowly as we move forward. I'll pick up the pace a little bit. But okay, so that evaluates those truth values. And now we have everything that we need. We have all of the information that we need to evaluate the main connective, right? So that's, of course, the main operator in the statement. I have a video on that as well, if you're not quite familiar. Okay, so moving on, right? Now let's go ahead, erase this. And let's evaluate the conditional, okay? So we know, just as a reminder, that a conditional is false when the antecedent is true and the consequent is false. And the conditional is true under all other conditions, right? So for this first row, we have P is true and not R is false, right? So a true antecedent and a false consequent. So that means that this is going to be false. Then we have true implies true, so that's true. We have false implies false, so that's true. And we have false implies true, so that's true, right? Now, this is where it can get tricky. I think most of the mistakes that my students have made when it comes to evaluating truth tables is just like careless mistakes, right? Not noticing that you're not looking at the right column, or you're not looking at the right truth value. So I'm going to use the highlighter here to mark the column of truth values that actually matters. So right here, these are the truth values for this statement, right? Not the ones that are under the negation. Maybe you want to erase those. I wouldn't, right? I think it's just better to highlight the ones that you care about. All right, so that's been evaluated. Let's move on to the next statement. So again, before we can evaluate this conjunction, right, we have to start with the negation, okay? So here, I'm just going to run through these. We know that P is true, true, false, false. So I'm just going to invert that, right? So false, false, true, true. And now that we have those truth values, we can go ahead and evaluate the entire statement. So we know that not P is false, right? And we know that a conjunction is true if and only if both of the conjuncts are true. Otherwise, the conjunction is false. For this first row, we already see that not P is false. So we know that this conjunction is going to be false. And once again, the same thing is true on the second row. For this third row, we see that not P is true. And it turns out that R is also true. So we know that that's going to be true. And then, of course, for the last row, we see not P is true. But it turns out that R is false. So this is going to be false. And we'll go ahead and we'll highlight that just so that we know all of our truth values. And now let's just go ahead and do the same thing for the last one. Here I'll move a bit faster, right? So for P, we know that the first row P is true, so that means that not P is false. False, true, true. And then let's go ahead and do the same thing with the conditional. So truth implies false would be false. False implies false would be true. True implies true, that's true. And false implies true, that's true. And I'll go ahead and I'll highlight these. Okay, now that we have all of our truth values, we can check to see whether the argument is valid, right? And now remember, especially in the case of truth tables, this is the most, I think the easiest definition of validity to have in mind. For an argument to be valid is for it to be impossible for its premises to all be true and its conclusion to be false. So if we can find a row, any row, with all true premises and a false conclusion, we know the argument is invalid. If there is no such row, then we know that the argument is valid. This means that we should start by looking at which conclusions, right? Remember, they're the highlighted ones here. Which one of these is false? And it turns out it's only the first row. So I'm going to go ahead and I'm going to highlight that row. Right? And what we're looking for is just whether it's got true premises and a false conclusion, and it does not, right? Both of these are false, and that's the only time that the conclusion is also false. So what we know is that this argument is valid, right? Why? Because there is no row that has all true premises and a false conclusion. Only when there is a row, at least one, where all the premises are true and the conclusion is false, do we know we have an invalid argument. If there is no such row, the argument is valid. All right, so I went pretty slowly on this first one. I know it's easy, we're just getting started. I'm going to move more quickly through the following two. So let's go ahead and move on. All right, so we have another argument here. Again, fairly simple. We'll go ahead and get started with the first premise because it's pretty straightforward. In this particular one, just because it's easy, that's what I'm going to do. If this were a more complicated one and I just wanted to get some of the easier ones out of the way first, I'd probably start with the conclusion because it's much easier to evaluate a negation than it is to evaluate all of the other connectives. But okay, let's start with the conditional. Truth implies truth, that's true. Truth implies false, that's false. False implies true, that's true. Hold on, that's not, there we go. And false implies false, that's true. Okay, moving on to the next one. Let's go ahead and start by evaluating not B, right? So we know that B is true, false, true, false. So not B must be false, true, false, true. And then we can go ahead and evaluate the conditional. If A is true and B is false, right? So true antecedent, false consequent, then we know that this is going to be false. Truth to truth is true. False, and these both start with false, so we know that these will both be true. And by the way, that's a good thing to keep in mind. Make your life easier, right? You don't have to look at every single statement when you're evaluating. If you really understand how the logical connectives work, you can just go right off of just one of the connectives, right? Because it's conditional and we know that a conditional with a false antecedent is always true, I don't even have to look at not B, right? Just by knowing that A is false in both of these, I know that this conditional is true. And then let's go ahead and evaluate not A, right? And in this case, the negation is the main connective. True, true, false, false. Therefore, the negation must be false, false, true, true. Again, I'll use my highlighter just to make sure that I don't make any mistakes. So we got, obviously in this case, it's maybe a little superfluous, but just for consistency, I'll go ahead and I'll highlight all of these. Right? And as before, what we're looking for is all true premises and a false conclusion. We have two false conclusions here, right? The first two rows of not A. But as you'll notice, neither one of these has all true premises, which means that we are once again dealing with a valid argument. And like I said, I haven't solved these before, so it might turn out that they're all valid. Maybe the next one will be invalid. So let's go ahead and move on. So this next one's going to be just a little bit harder. Mostly because now we have 3 atomic statements, right? So if there are 3 atomic statements, we need 8 rows in order to get every single possible combination of truth values, right? So I've already set that up so we don't have to waste time on that. This time around, I'll go ahead and I'll start with the negations just because it's, I think, easier to do that, right? So I'll start with the conclusion. In this case, the conclusion has alternating truth values, right? Starting with truth and then next false. So true, false, true, false, true, false, which means that this conclusion is going to go false, true, false, true, false, true, false, true. Nice and easy, right? And we'll go ahead and we'll do the same thing now with this premise over here with not N, right? Because again, we just have to invert them. So true, true, false, false, true, true, false, false is what N is, which just means that not N is the opposite. So we'll go ahead and we'll do false, false, true, true, false, false, true, true. Nice and easy. Okay, and then just for consistency, I will go ahead and highlight these. It's not really necessary here just because we're not going to have any additional truth values in any of these columns because the connectives are pretty straightforward, but I still like to highlight them. It just makes it easier. Okay, so now let's go ahead and do these other two premises. I'll start with the first one. So we have A or N, right? So we know that a disjunction is false if and only if both disjuncts are false. Otherwise, it's true, right? So if either one, A or N or both, are true, then we know that the disjunction is true. So first row, we have both true, so this will be true. Second row, we have both true, so this will be true. Third row, A is true, so this must be true. Fourth row, A is true, so this must be true. Fifth row, N is true, so this must be true. Sixth row, N is true, so this must be true. And then for the seventh and eighth rows, they're both false, so I will mark them as both false there. Right, we'll go ahead and we'll highlight that. And then finally, this last one, another conditional. We should be sick of these by now. They're pretty easy, right? So we have A implies T, right? So we'll want to make sure that we're always looking at the right columns, right? In this case, of the first three atomic statements, it's the first and third, right? All right, so truth implies truth. That's going to be true. Truth implies false. That's going to be false. Truth implies truth. That'll be true. Truth implies false. That's false. And then these last four, A is false for all four of these rows. We know that the conditional, if it has a false antecedent, is going to be true, so we can just go ahead and write true for all four of these, right? And that makes sense. It doesn't really matter what T turns out to be, right? So if it turns out that T is true, well, false implies true, that's true. And if it turns out that T is false, well, false implies false, that's also true. So this is where it's useful to know your functional connectives, right? To know how to evaluate those. It can make your life much easier. All right, so with that done, we can now, I'll go ahead and highlight these again just for consistency. We can go ahead and we can evaluate this argument to see whether it is valid. So as before, we'll just go ahead and we'll look at all of the rows where the conclusion is false. So that seems to be this first row, this third row, this fifth row, and this seventh row. And now we're going to go ahead and see if we can find any one of these rows that has all true premises. This first row has one false premise. And there we go. Right here, we have a row that has all true premises and a false conclusion. So this argument is invalid. All right, so that pretty much concludes this video. I'm going to go ahead and I'm going to keep uploading these, right? Now, I might make more easy, more intermediate, more hard videos. So stay tuned if you're looking to practice your logic. I'll see you around.